we go over now phase diagrams. Now, phase diagrams are simply diagrams which give us information about the relationship of different states of a substance in different phases. So we're going to start with a phase diagram for carbon dioxide. So let's have the phase diagram for carbon dioxide here and also the phase diagram for water, like that. Okay. So on the y-axis there is pressure there, it's in atmospheres, and on the x-axis what we have is temperature. It can be in Kelvin on any unit. So same here, we've got pressure in atmosphere and then Kelvin. So for the first diagram I'm going to be talking about carbon dioxide, and the other one that is going to be for water. Now the phase diagram for carbon dioxide, so we are going to start from here. It goes in that direction. Okay, let me start like that to be more like that, and then it goes like that. Now for water the phase diagram is a bit different. So it more goes like that and then like that. So the difference is for carbon dioxide, this slope is positive. So it more makes a line which is like this. But for water, the slope is negative. This slope here. Alright. Now, what are some things that we can learn from this diagram? The phase diagram for water and the phase diagram for carbon dioxide. Let me start with the carbon dioxide phase diagram. For the phase diagram for carbon dioxide, 1 atmosphere is below this point. So that is where 1 atmosphere is. So that is called the standard pressure. 1 atmosphere, that is a standard pressure. So this point, this is a point where you are going to have a solid, liquid, and a gas existing at the same time. So this region is always a region for solids. This is a liquid region, and then this is a region for gases. Okay. Now, this point where everything exists at the same time is called the triple point. So let me label it in this way. So this value here is the triple point. So I'll just put TP, triple point, meaning that the three of them at the same time. Now, of course, we know the conversion, if you change a solid into a liquid, this process happens when you add, of course, when we add heat to a solid. And the change of state from solid to liquid, this is called melting. And when we are changing a solid, let me say the opposite way. So when this one goes into that one, that's called melting. But when a liquid goes into a solid, what do we call that? Well, that is simply the opposite. Now let me put them on one diagram so that we get to just use one. So let's have a solid here, let's have a liquid there, and let's have a gas at this point. So the conversion of a solid into a liquid, this is what we are calling as melting. We've melted something. And now the opposite, which is the conversion of a liquid into a solid. For example, if we get water we put in a refrigerator, that is freezing. Now, what of if we convert a liquid into a gas? So when a liquid goes into a gas, that is called vaporization. Okay. Or simply evaporation. But the other way around, when a gas is going into a liquid, this is called condensation. Well, again, the change of state of a solid when a solid changes into a liquid, I mean a gas, direct into a gas. What do we call such a change of state? And the opposite, when a gas changes into a solid. Well, the conversion of a gas into a solid is called sublimation. And the opposite, when a solid is converted into a gas, that is called deposition. All right, so that is it. So a gas into a solid actually is just the little opposite of what I've said. So solid into gas, that is what we call as sublimation. Okay, we say a solid as sublimed. For example, you can have solid carbon dioxide. So when that solid goes into a gas, that is sublimation. Now the other way around, when a gas changes state into a solid, that is now called deposition. So we got to pay attention to that rest we mix them. Okay, and so that is telling us from the first diagram which we have here, the change of state at this point when a solid is going into a liquid. So I've got a solid into a liquid. Of course, this is supposed to be solid into liquid. That is supposed to be, we can see solid, liquid. That is supposed to be melting. We can just think of it more in terms of water. So this is supposed to be melting. So this line which is here is called a melting point line. This line is a melting point line. Okay, that is it. So that means on any place on this line, a solid can go into a liquid. Just at any point on that line. Just any point on the line, a solid can go into a liquid. So that is it. Alright, now at the very end here, at this point, I'm going to put another line. I'm going to put a line like that and a line like that. So the entire of this region which we can see, we cannot distinguish between a liquid and a gas. So that in that region, that is what we call, we have got what is called a supercritical fluid. Supercritical fluid in this region. So a supercritical fluid is a fluid which is liquid and gas at the same time. It is purely gas and purely liquid. So we can't differentiate whether it's liquid or gas, but it is both. Okay, so that is a supercritical fluid. And then this point which we can see here is called the critical point. Okay, that is called the critical point. Now, another thing that we get to note now, let's use first the diagram for water. We see some things which we can get from there. We've talked much about carbon dioxide. So on top here we've got 1 atmosphere for water. So for carbon dioxide, 1 atmosphere is below the triple point, but for water it is above the triple point there. Okay, so still we have got a solid here, a liquid here, and a gas here for water. Now, at this point here, we are going to have a supercritical fluid in this region. So this is the critical point. Okay. Now if we drop at the very critical point, if we drop, we go on the x-axis, we are going to have the critical temperature, and then if we go on the y-axis, we are going to have the value we are going to read here is the critical pressure. So those are the two values. Now, another thing that we can note from this, so this point, of course, we are saying a solid being converted into a liquid. This is melting. So melting can happen anywhere on this line. That is called the melting point line. But the normal melting point of a liquid, a normal melting point of a liquid is found when the temperature is 1 atmosphere. Sorry, not temperature but pressure. When the pressure is 1 atmosphere. So let me just make this line well so that we get to see some other things that we're going to talk about. Let me make it like that because it more increases. Okay, better like that. Of course, we are saying this is going to be a liquid in this region. Now, at this point, that is where we're going to have the supercritical fluid. So we have got a critical point here. Okay. Now, we are saying the point when the temperature is exactly, I mean, the pressure is exactly 1 atmosphere. That is when we have got a standard pressure. Because melting can happen at any point on this line. But the normal melting point happens when the pressure is 1 atmosphere. So the normal melting point is going to happen at this point. So this is going to be called the normal melting point for water. So whenever we put normal in front of the melting point, that should mean we are talking about 1 atmosphere. But if it's just a melting point, it can be anywhere on this line. And the conversion of a liquid, this is a gas. The conversion of a liquid into a gas, that is simply evaporation. So we can talk about boiling in that case. So the normal boiling point happens when we are talking about 1 atmosphere. So this very point here, this is the normal boiling point for water. Okay. Now, at a very normal boiling point, of course, boiling can happen on any of this on this line. That is where the conversion of a liquid into a gas can happen. But whenever we're referring to normal, we only talk about that very point when when the pressure is 1 atmosphere. So these are some things that we are able to learn from a phase diagram. Well, from here we can see that if we have got a solid, let's say we have got a solid at this point, it is having a certain pressure here and a certain temperature here. So if we begin to change the temperature of that solid, let us not even change the temperature, but if we begin to lower the pressure at constant temperature, so starting to lower the pressure, we see that this solid is going to directly convert into a gas. So in other ways, it undergoes sublimation. So a solid, for carbon dioxide, solid carbon dioxide can easily undergo sublimation. But if you are talking about water, if you have got, let's say, water at this temperature, if you want to convert it into a gas, when you start to lower the pressure at constant temperature, you are not changing the temperature, but you are changing the pressure. You are lowering the pressure. It will first go into a solid, and then it will go into a gas. And then another thing is, if you have got, let's say, a compound at this temperature and pressure, a certain pressure here and a certain temperature here. So what happens if you start to increase the temperature without increasing the pressure? So the pressure is held constant. You see that it's going to be converted into a gas. So in other words, the change of state that is going to be happening is a solid to gas, and that is sublimation. So from here they can give us some certain temperature and pressure, and they can tell us if we change the temperature to this and this, what will be the new state. So we all get it from here. Let's say the value here is 0 0.5 atmosphere, and then the temperature here is, let's say, 25. Okay, let me just say 100 Kelvin, and then at this point the temperature is, let's say, 370 Kelvin. Now, if we've been given a substance which is at zero point 0.5 atmosphere and 100 Kelvin, and then we increase the temperature to 370 Kelvin without changing the pressure, what will be the new state of that substance? So it is here, but if we increase the temperature to 370 without changing the pressure, it will come here. So that means it is now a gas. The change of state that is happening here is sublimation. What if we change the temperature, let's say to 370, and the pressure goes to 1 atmosphere? What will be the state? So it is going to, so the temperature is gone to 370 and then the pressure has gone to 1. So it will be at this point. So it has changed from a solid into a liquid. The change of state that has happened, solid to liquid, it has melted. So basically this is what happens when you're using a phase diagram. It's ought to understand changes of state happening when you've been given one pressure and the other. One thing to understand is this is a triple point and this is a critical point. At the critical point you have got the critical temperature and critical pressure. And for 1 atmosphere, that is where you find the normal boiling point and the normal melting point of a substance. Well, that would be all for this video. Thank you so much for watching. Hope it was helpful. Stay blessed.